The correlation between two devices have been extensively used to evaluate whether two devices can be comparable, right? But also you can find a correlation algorithm or statistics in order to determine the repeatability or reproducibility of a given device. The visual have been extensively evaluated, and it have been probably has the largest validation in the market. And by validation, I mean peer review validation. But not only peer review validation, but also it has been independently validated by many respectful and respected scientists. So we're proud that our technology have been tested somewhere else. The correlation when we're comparing Humphrey and the visual, to obtain the correlation, you can use different statistics. The one that is used the most is the Pearson correlation or R square correlation or Spearman correlation. It depending on the kind of population that you're looking at, the behavior of the population that you choose which statistic to evaluate the correlation. Usually the correlation, it's a number that goes between 0 and 1. The closer to 1, the better the correlation. The closer to 0 the number, the least correlation between these two devices. Okay. The correlation, like I mentioned, depends on many factors. And one of the factors is, of course, the reproducibility of the units or the devices. It is very common to find very high 0.90 something correlation in objective devices like optical coherence tomography because it doesn't depend on the subjectivity of the observer or the subjectivity of the patient. But when we are talking to visual field devices, where it is a purely functional test and is highly subjective, then those correlations tend to be lower. That's what we usually expect